All right, in Business Calculus 11.9, we're going to be discussing the continuity and differentiability of a graph. So this is asking find all the points of discontinuous for the function whose graphs are drawn below. So when I'm looking at the graph for number 1, first off, graphs are discontinuous anywhere you have a vertical asymptote, you have a hole in your graph, or if we have jump discontinuity. So as I take a look at this graph for number 1, this has a vertical asymptote right here at x equals 0. We have a hole right here at x equals 2. So when it asks you for those x values for where the graph is discontinuous, that's going to be at x equals 0 and x equals 2. The next graph, number 3. I only have one point, a hole, so that's a point discontinuity. And again, we're looking for that x value where that occurs. So this x value right there would be at x equals 1. So this is discontinuous at the point x equals 1. So again, they're just looking for these x values of where the graph is discontinuous. My example number 5, where is the graph discontinuous? So if I'm taking a look at it, I see one break here, a second break, and a third break. So I'm going to have 3 points of where this graph is discontinuous. So that happens to be discontinuous at x equals, hopefully you're thinking right here, -3. Right here, this x equals 0, and then this x equals +3. So again, everywhere you see this jump or a vertical asymptote, that is where a graph is discontinuous. All right, the next section is going to ask us, are the given functions continuous at the given values for x? So basically we're being asked, if we were to plug 0 into this function, does that value exist? See, so if I take this x equals 0 and plug it into here, I get 4 over -2, and that would exist. So it is continuous at x equals 0. But let's say I took the value of x equals 2 and I plugged it into here. That would be 4 over 0, which does not exist because we can never divide by 0 in our life. So therefore, at x equals 0, the graph is continuous, but x equals 2, it is not continuous. That would be that vertical asymptote at x equals 2. All right, number 11 is the next one we're going to look at. So again, we're being asked, is it continuous when x equals 0, when x equals 3, and when x equals 5? Now let's take a look at this right here. If we go back to our Algebra 2 and back to our college algebra, we know we have a vertical asymptote at x equals 0. Our graph is definitely discontinuous at x equals 0. We have another vertical asymptote at x equals 3. So it's also discontinuous at x equals 3. So when I'm asking you, is it continuous when x equals 0? Well, if you put 0 in here for x, it's going to be undefined. So no, it's not continuous at x equals 0. This says at x equals 3. Again, if I plug 3 into that right there, x minus 3, 3 minus 3 is 0. See, I would be dividing by 0 again, which is undefined, and that we cannot do. So therefore, it's also discontinuous at x equals 3. It asks then, is it continuous at x equals 5? Well, if I put in 5 here, that'd be 5. That would be 2. This would be at 1/10. So my graph is continuous at x equals 5. Number 13. The easiest way to know for 13 if it is continuous or not is if we were to have factored that denominator. Now, that denominator factors, I'm going to have to move the camera for just a second here. That factors to x minus 2 times x plus 1 on the bottom. So when you factor that right there, I know that at x equals 2, it's discontinuous. That's a vertical asymptote. At x equals -1, it's discontinuous. Again, that would be a vertical asymptote. So what about at x equals 1? See, at x equals 1, the bottom is a 2. This bottom is a -1. So that's okay. X equals 1 would be continuous then. It doesn't give me 0 in the denominator. At x equals 2, right there, that gives me a 0 in the denominator. That would make this undefined. Therefore, at x equals 2, it is not continuous. At x equals -2, that would be -1. That would be -4. So yes, x can equal -2. All right, so for number 15, again, it wants to know where is it continuous or not. So if I'm taking a look at x equals 0, yes, this would be continuous at x equals 0. Plugging in 0 would give me -4 over -2, which is okay. But see, if I was to plug in 2 into the numerator, I get 0. In the denominator, I get 0. The problem is getting 0 in the denominator. So my graph is discontinuous at x equals 2. If I plug in -2, the denominator, I get a -4. The numerator, I get 0. 0 divided by -4 is 0. That is okay. So it is continuous at -2. So again, the only point of discontinuity is when that denominator was 0, which happens to be when x equals 2. That's where it was discontinuous. All right, 17 was those piecewise functions that we did in Algebra 2 and in college algebra. So what we need to understand is that this is a graph of the line y equals x minus 2, but only starting from where x is 3 and the number is smaller. This is the line 2 minus x, but only again from where x is 3 and larger. Now, y'all, at x equals 2, that would be only into the first line. So 2 minus 2 would be 0. This is continuous. But the only way for x to equal 3 to be continuous is if I plug 3 into the top one and 3 into the bottom one, and if they're the same. If they're not the same, then it would not be continuous at 3. So plugging in the 3, 3 minus 2 would be 1. 2 minus 3 would be negative 1. So this is actually discontinuous at x equals 3. If you give me just a second, I'll kind of try to make a little graph for you to show you this. So if I'm plugging 3 into that first one, 3 minus 2 would have given me 1. If I plug in numbers smaller, like 2, for example, that would have given me 0. And then that would be that part of the line. We'll get that in a picture in a minute. The next one would be if I'm plugging in 3 into here, 2 minus 3 would be negative 1, and it's an open circle. And then if I was to plug in a number bigger, like 4, so 2 minus 4 would be negative 2 when x was 4. And so this is a picture of what that graph would look like. And again, y'all, we would make XY tables of these, and so we would understand how to make this graph. So it's going to be really important that you understand how to make the graph as well. So again, the breaking point was at x is 3. The first one was solid because it was underlined, and the number is less than, so I plugged in 2. The second one was greater than 3, so I did an open circle at 3, and then plugged in a number bigger like 4, and then drew my two sections. Now remember, if these two y values were the same, my graph would have been continuous, but they're not the same, so it is not continuous. Okay, in the next section, they're giving you the equations, and they're asking you state x values where the function is discontinuous. So looking at number 19, that function happens to be a parabola that opens up. It's never discontinuous. So it said find the x values where it's discontinuous. There are none for 19. It's always continuous. All right, for 21, when you have a square root, when you have fractions, the denominator can never be 0. So on number 21, your graph is discontinuous when the denominator equals 0. That means that x equals negative 4. All right, on 23, we have a square root. Let me kind of zoom that one in a minute. So on number 23, you have e raised to that is just not getting unblurry for me. So e raised to the square root of x minus 2. So e can be raised to any power. The problem is for this to be continuous, it would have to be what's under the square root bar would have to be greater than or equal to 0. So I know that the graph is continuous for x minus 2 greater than or equal to 0. It's kind of like the domain in this situation. X is greater than or equal to 2. It is where it's continuous. Now the question wanted to know where was it discontinuous. So my graph would be discontinuous, meaning kind of like where it doesn't exist then, I guess. It would be discontinuous then from x is less than or equal to 2. Alrighty, on 25 through 27 are more of the piecewise functions. It says a graph the given function, and then B, find all the values of x where the function is discontinuous. Okay, so on 25, the first thing I would want to do on the first one, it says y equals 2. As long as x is equal to less than 1, So you should get in the habit of making that xy table. So the first function is f of x equals 2, provided the x's are less than 1. So again, I start with 1, but I know it'll be an open circle, and the number smaller than it, and all those y's will always be 2. The second function said f of x equals x plus 3. Now this time my x's are only going to run from 1 to 4. The 1 would be solid. The 4 will be open. Okay, and I'll show you my xy table here in just a second. The last function was f of x equals 8, and that was provided the x's were greater than or equal to 4, and it's closed on the 4 and numbers bigger. So here was the first part of that. F of x equaled 2, provided the x was less than 1. So I started with 1, open, and the number smaller, and all those y's were 2. The next function was x plus 3, and it said x's had to go from 1 to 4. Okay, so the x's went from 1 less than or equal to x less than 4. So notice I did a solid circle, I did an open circle, and I do x plus 3 for each one. So 1 plus 3, 2 plus 3, 3 plus 3, and 4 plus 3. All right, the next one said all the f of x equals 8, provided x is greater than or equal to 4. So I did a solid circle because it's underlined. And this said x starts at 4 and goes larger. And this says y equals 8. There's the y equals 8. All right, so when we take a look at the graph of this, from the very first one, right there, I need an open circle at the point 1, 2. So get your piece of paper, pause it for a second, and then come back to the video. All right, so hopefully you're back from pausing it. You went to 1, 2, made an open circle, 0, 2 made a dot, negative 1, 2 made a dot, and then you want to draw that part of the graph. Okay, the middle piece. The table says go to 1, 4, and make a solid dot. Go to 2, 5. It passes through 3, 6, and 4, 7 is open. And then you want to connect those 4 points. That's what that part of the graph should look like, this piece right here. Third one, you want to plot the point 4, 8 solid, plot the point 5, 8. So again, you're going to go to 4, 8 solid, 5, 8. And it's going to pass through 5, 8 and go in that direction forever. So that's the third piece. So when we're talking about here, where is the graph discontinuous? See, the graph is discontinuous at x equals 1. It is also discontinuous here at x equals, I think that was x equals 4, at x equals 4. So again, where these jump discontinuities are is where your graph is discontinuous. So it was discontinuous at x equals 1 because these two y values are not the same. It was discontinuous at x equals 4 because these two y values were not the same. Had they been the same, it would have been continuous there. I hope that helps you making your piecewise graphs. You guys have done these in Algebra 2, in college algebra, and now you're doing them again in business math. Make sure, it's very important that you make these XY tables. Make a note like the open and the closed circles. Plot those points, and then do that part of the connecting of the graphs. I wish you the best of luck on this assignment. I think you guys can do it.